40,000 years later, under the faint light of an unknown star, a piece of ancient metal floats in the cold, dark expanse of interstellar space. This is Voyager 1, which was sent by human civilization in 1977. Suddenly, an unknown civilization has spotted this spacecraft. Their eyes fall on a shiny, gold-plated golden record on which the sounds of Earth, music, and many images are recorded. They touch it, and in an instant, the voices of the millions of years old human civilization echo before them. But will they be able to understand it? And will this message really be able to tell our story? This scene leads us to a question. In 1977, when Voyager 1 and Voyager 2 bid farewell to our solar system with the golden record, they carried a time capsule of our world with them. But today, if we launch Voyager 3, will we send another golden record like that again? Or will the technology of our digital age help us do something else, something more complex? Something bolder? How will we tell our story to those distant civilizations in the endless darkness of interstellar space? And will there really be anyone out there to listen to our story? In 1977, when Voyager 1 and Voyager 2 left Earth, they were not just machines, they were messengers of humanity. They were sent to explore the outer planets of the solar system: Jupiter, Saturn, Uranus, and Neptune. A rare planetary alignment gave them the opportunity to hop from one planet to another using gravity assist. Voyager 1 visited Saturn's moon Titan and then left the solar system, heading into interstellar space. There was a message, the golden record, an idea that came from Carl Sagan and his wife Anne. With the help of Frank Drake, John Lomberg, and National Aeronautics and Space Administration, this record included 115 pictures, sounds of nature, music, and greetings in 55 languages. Messages from American President Carter and United Nations Secretary General Waldheim were also included. This was a phonograph record made of gold-plated copper, and it came with a very advanced stylus. Launched in 1972 and 1973. On the Pioneer spacecraft, only the name of the craft and the origin of our Earth were written, but the golden record itself was a complete story of Earth, of our humanity, and of our hopes. It was placed in an aluminum cover which had a layer of uranium-238 on it. Uranium was used for two reasons. It is 5 times more effective than lead at blocking cosmic rays and X-rays, and its decay should provide some information. Some believe that it could be dangerous, but the Voyager spacecraft are moving so slowly, at a speed of about 56,000 to 61,000 kilometers per hour. They're close to our star. It would take 77,000 to 84,000 years just to reach Proxima Centauri, and they're not even heading toward Proxima Centauri. First, they would have to cross the Oort cloud, which is the outer shell of the solar system, and just that would take them about 20,000 years. That's such a long time that it's beyond our imagination, and by then, we might have become a spacefaring civilization. But the question remains, if we send Voyager 3 today, will we send something like the golden record again, or will our technology show us a different way? Will our message still be that simple, or would we want to throw something more complex into the cosmic ocean? The golden records of Voyager 1 and Voyager 2 are among the most daring attempts of human civilization. Even though we sent them off completely protected, are these records really in a place where interstellar dust the particles of which are even smaller than a micrometer? They collide with Voyager at speeds of about 50,000 to 70,000 kilometers per hour. Each collision creates a tiny crater which slowly forms on the surface of these spacecraft and maybe even on the gold record itself. Apart from this, charged particles from the solar wind and cosmic rays coming from supernova or black holes can knock atoms out of the crystalline structure of the golden record. Over millions and billions of years, these processes can weaken the records. National Aeronautics and Space Administration had already understood this risk. That's why the golden records have been placed in an aluminum cover, which has been coated with uranium-238, which would use advanced technology from interstellar space. How could they possibly understand it? The golden records are based on 1970s technology with images and sounds in analog waveform and 512 vertical lines. It was a miracle then. But today, it's heading toward a red dwarf star called Ross 248. Which is about 17 light years away, and it will take more than 30,000 years to reach there. However, it will face less interstellar dust. But Voyager 1, which the galaxy estimates, these records can last for about 5 billion years. But by then, the Milky Way and Andromeda galaxies will collide. What will happen to Voyager in this collision? Olber's model suggests that there is a 20% chance that Voyager will enter a new galaxy during this time. So will we rely on such analog technology again, or will our modern technology show us a new path? The golden record dared to take the story of humanity to interstellar space in the 1970s. We are living in a phonographic record era. If we launch Voyager 3, will we rely on such analog technology again, or will our modern technology show us a more powerful, more complex, and riskier path? In today's world, a centimeter-sized quartz disk can store 360 terabytes of data. That's millions of times more than the golden record, and these disks can last 14 billion years, longer than our sun's lifespan. The golden record contained 115 pictures, some music, and greetings in 55 languages. But on a quartz disk, we can store entire books, videos, scientific data, and maybe even a summary of the entire internet. But this is where a mysterious challenge arises. Data is written on a fused quartz disk at the nanometer scale in 2 optical dimensions and 3 spatial dimensions. To read that data, you need a technology that perhaps only an advanced civilization would require. Are we ready to take the risk that some unknown civilization might not be able to understand our complex technology? There's another question. If we send an electronic reader with Voyager 3, will it be able to withstand the harsh conditions of interstellar space? Cosmic rays, interstellar dust, and charged particles can destroy any electronic devices over millions of years. Even though the fused quartz disk may last for 14 billion years, the equipment to read it was like a vinyl record which anyone could understand without complex technology. But today, our digital world gives us the opportunity to send more data, more stories, and more complex messages. But the question is, will we choose quantity or simplicity? Will we choose for our message to reach every civilization or only the most advanced ones? And if we send Voyager 3, will our message become a shining star in the cosmic ocean visible to everyone, or will it just become silent debris? The golden records of Voyager 1 and Voyager 2 had the courage to send the story of human civilization into interstellar space. It was an attempt filled with hope and curiosity. But if we launch Voyager 3 today, some people had given warnings while making the golden records. Should we give our information to unknown civilizations like our location, our culture, and our weaknesses? What if a hostile alien civilization uses this information for something worse than just wrong? This means that if any civilization finds these probes within our lifetime, then maybe they are already present in our solar system. But this risk isn't limited to just hostile aliens. If we send a new message with Voyager 3, like a fused quartz disk which can store 360 terabytes of data, so if it somehow falls into the wrong hands, what could be the consequences? Today, in our digital ecosystem, data brokers, personalized ads, and online tracking have turned our personal information into a business. Our email, name, address, age, and profession, such information is sold just to exploit us. We have the right to decide whether the story of our civilization should be sent into the universe. If we send our entire digital history, our wars, our mistakes, our achievements with Voyager 3, if we send all this, then are we Will the message of Voyager 3 be our hope, or will it become our greatest mistake? Voyager 1 and Voyager 2 have sent a time capsule in the form of golden records, which millions or maybe billions of years from now will collide with some unknown Milky Way and Andromeda galaxies. So these Voyagers, or at least their golden records, might still be floating in this cosmic ocean even then. Interstellar dust and cosmic rays might have worn them down, but those records protected by uranium-238 will remain safe, preserving the last traces of human civilization wandering somewhere, waiting for someone. If some civilization finds them, they will hear our laughter, our lives, our music, and our dreams. They will know that a small planet, a tiny blue dot, once wanted to reach the stars. But what will Voyager 3's message be? As Carl Sagan said, our message should be very simple so that every civilization can understand our story. Or will we rely on techniques like nanoscale, knowing that perhaps only the most advanced civilizations will be able to read it? And will we take the risk that our location, our vulnerabilities, might reach a dangerous civilization? This is a puzzle that forces us to think about how to define our place in the universe. This story is not just about the Voyagers, it's our story. It's the story of that curiosity that took us beyond the Oort cloud. Ross 248 Jai. In 1977, National Aeronautics and Space Administration launches two of the most ambitious missions in human history, Voyager 1 and Voyager 2. These twin spacecraft were designed to study the outer planets, and after that, they have been transmitting data from the outer regions. They are moving further into the dark corners of space, where nothing made by humans has ever reached before. Voyager 1 is now more than 14 billion miles away from Earth. Meanwhile, these spacecrafts have become a symbol of human curiosity and our obsession with uncovering the mysteries of this universe. But how long will this mission continue to explore the infinite universe as it moves forward? What could be the possible end scenarios? As these spacecrafts continue to move forward in the cosmos, what challenges will National Aeronautics and Space Administration have to face? We will find out where the limits of our technology lie. In today's INF 277, we will see how far this mission has reached since its launch. Voyager 1 and Voyager 2 were originally designed for a grand tour of the outer planets of our solar system, which is rare due to a rare planetary alignment, as such an alignment happens only once every 176 years. So, keeping this alignment in mind, two missions were designed. The first was Voyager 1, whose primary mission was to fly by Jupiter and Saturn and transmit the valuable data collected there back to Earth. The second mission was Voyager 2, whose journey was going to be a bit longer than Voyager 1 because it was to pass by all the major planets, Jupiter, Saturn, Uranus and Neptune, and performed even better. And it sent us the latest images of those planets, groundbreaking data, and pictures of their moons as well. This greatly improved our understanding of the outer planets of our own solar system. That means this spacecraft was the first to cross the heliopause and enter interstellar space. The heliopause is the boundary beyond which the sun's influence fades away, and beyond that lies the interstellar medium. We face problems communicating with them. Sometimes we also see glitches in these spacecraft, but somehow National Aeronautics and Space Administration still manages to communicate with them. The signals we receive from both these spacecraft are 20 billion times weaker than the energy required to run our digital watches. They are equipped with a thermoelectric generator or radioisotope thermoelectric generator, which generates electricity from the heat released by the decay of plutonium-238. Over time, the output power generated by the radioisotope thermoelectric generator has been continuously decreasing. Because of this, it's not possible to keep all the instruments on the spacecraft running. That's why National Aeronautics and Space Administration has managed the spacecraft's power consumption very carefully. Because of this, it will break, but the question is, what will happen then? Will this historic mission end at this point? That's why National Aeronautics and Space Administration has managed the spacecraft very carefully. The process will not be affected. That's why National Aeronautics and Space Administration has managed the spacecraft very carefully. That's why National Aeronautics and Space Administration has managed the big spacecraft. And when this happens, the Voyagers won't be able to communicate with our Earth, neither will the Voyagers be able to send us signals, nor will they be able to align themselves precisely towards Earth to send signals. Because all these tasks are done by the instruments installed on the Voyagers, and when this happens, all the scientific instruments on the Voyager will stop working. But even after losing power, the Voyager will continue its journey in this vast universe just like this. It will quietly continue to carry out a very ambitious mission sent by humans. Yes, the most precious thing on the Voyager is a phonograph record on which we humans have recorded various sounds from Earth on both Voyager spacecrafts. Yes, the most precious thing on the Voyager. If it falls into the hands of some highly advanced intelligent extraterrestrial life, then in the real sense, this mission will be accomplished. But until then, it will keep traveling through the universe, representing our planet, us humans, and our humanity, that is, the human race. It will quietly keep carrying our message to other parts of the universe. However, we will never know what will happen to Voyagers after we lose contact with them. Will this spacecraft really deliver our message to aliens, or will its fate be something else? A deep mystery will always surround it. But one thing is certain, this journey could continue for thousands, millions, or even billions of years to come. Another possible scenario could be that the Voyager spacecraft collide with an object in interstellar space. However, the chances of that happening are quite low because space is much bigger than we can imagine, and compared to that, spacecrafts are very small. In such a case, a head-on collision with any object is almost impossible. Interstellar space isn't empty, but it's extremely sparse. That means its density is so low that in interstellar space, you find only one atom in a cubic centimeter, which is much less than the density of our solar system. That's why, in the vast expanse of the universe, the chances of a spacecraft colliding with something are very low. Even if the Voyagers collide with something in interstellar space, it will most likely be a tiny grain or an interstellar dust particle, and if our spacecraft collides with such a small particle, nothing will happen to it. The small size of the particle and its small relative speed won't be able to cause much damage to our Voyagers. In fact, if you see, Voyager 1 and Voyager 2 collided with many such particles while leaving our solar system, but these had no effect on the performance of the Voyagers. But yes, if the Voyagers collide with a large object like a small asteroid or a comet, the consequences could be quite disastrous. Right now, the Voyagers are traveling through interstellar space at approximately 17 kilometers per second. And at such a speed, if they collide with even a small object just a few centimeters in diameter, the event would be catastrophic. This impact would destroy the spacecraft, its pieces would scatter as debris all over space, and such an end would be quite emotional for us. We know that in such a collision, nothing would be left of the Voyagers, but the chances of this happening are quite low. Voyager is traveling to those parts of the universe that are almost empty, where the chances of a collision are nearly zero. And even if that happens, it will be after millions of years, and by then, the Voyagers will probably have become chapters in history books on Earth. We can add another strange scenario to Voyager's journey. It's possible that during their journey, the Voyagers might enter another solar system, and that could be the final destination of their journey. However, we are considering this entire scenario as hypothetical, and it would take millions of years for something like this to happen. But this would prove to be a new turn in Voyager's journey. Both spacecraft are moving forward on their decided trajectory in interstellar space in such a way that Voyager 1 is heading towards the constellation Ophiuchus and Voyager 2 is heading towards the constellation Sagittarius. If these spacecraft keep moving at the same speed, in the next 40,000 years, Voyager 1 will reach within 1.6 light years of a known star, Gliese 445. Meanwhile, Voyager 2 traveling through this infinite universe will be within 4.3 light years of a star called Ross 248 after about 296,000 years. Although these distances may seem very large to us, if we look at it on a cosmic scale, they are nothing. If these spacecraft get very close to those stars or reach right near a star system, their trajectory will change because of that star. It is possible that these spacecraft may pass very close to the celestial body present there. In such a scenario, the Voyagers will become the first man-made objects to enter another star system. Even though our Voyagers will visit another star system, by that time, due to the lack of a power source, they will remain completely inactive. By the time they reach that star system, their power source will not be generating any energy at all. That's why they won't be able to transmit any signals to those celestial bodies or to Earth. That means even if this happens, we will never know what happened to the Voyagers in their final moments. If there is intelligent life present in that star system, they will definitely notice the Voyagers. And after seeing an artificial object like Voyager, they will try to capture it. So what will happen when this scenario becomes reality? Discovery by an alien civilization has increased the chances of Voyager's confiscation, which was sent by the people of Earth to those extraterrestrials. This has been seen as an act of kindness. It is a message. The golden record contains sounds and images that depict life here, that is, on this earth. Greetings have been sent to those aliens in 55 languages.
On behalf of my country, I send a message of friendship and goodwill to our friends who live in space.
Music from different cultures, pictures of people and animals, and images of Earth's landscapes were also included in the golden record. We are very eager to communicate with anyone in this universe. Halak, the chances are almost zero that any alien civilization will be able to discover the Voyagers. But still, this possibility makes all of us curious. Even if we assume that an alien civilization has discovered one of the spacecraft, we will never be able to find out about it. The challenge is also that those advanced aliens will have to decipher the messages sent on the golden records. Only then will those aliens be able to learn about us and the life thriving on our Earth. And in this way, the Voyagers are representing our human civilization in this infinite universe. If we say that even if the Voyagers are never found by aliens, even then the Voyagers will keep wandering in this infinite universe carrying the message of our humanity. It is this spirit of exploration that makes us humans exceptional. The golden record is a reminder of how we are always ready to explore this universe and connect with it. We don't want to be alone in this infinite universe. We are looking for a companion who won't let us feel lonely on this cosmic scale. And we hope that one day our efforts will definitely succeed. The Voyager spacecraft will be recorded in history, and by then they will become the farthest traveling spacecraft in human history. We looked at the different end scenarios, and we also remembered the remarkable achievements of these spacecraft that they are leaving behind. We saw the different scenarios of Voyager, and these spacecraft are leaving behind their remarkable achievements. Launched in 1977, National Aeronautics and Space Administration is Voyager 1 and Voyager 2 spacecraft have embarked on an extraordinary journey for our human civilization. Today, as they travel through this infinite universe, they have gone much farther than any other man-made object. The original Voyager mission was designed for only a 5-year mission period to explore Jupiter and Saturn, but the Voyagers performed far better than scientists had expected. It completed all its missions on time and then was sent on to further missions. It was sent again on a never-ending journey through this infinite darkness-filled universe. And today, Voyager 1 is about 14 billion miles away from our Earth, and Voyager 2 isn't far behind either. And it is continuously traveling through this infinite darkness-filled universe. But the question is, how did National Aeronautics and Space Administration manage to keep these spacecraft operational for such a long time despite such a great distance and harsh space conditions? To keep them alive, cleverness, skill, talent, and maybe a little bit of luck were also necessary. Carefully managing power, continuously providing accurate software updates, and overcoming technical challenges. The Voyager mission team has made every possible effort to continue the historic journey of these spacecraft. In today's video, we will explore the strategies and techniques that National Aeronautics and Space Administration has used to keep these Voyager spacecraft operational for more than 4 decades. What kind of challenges did these distant explorers face, and how did the mission team implement clever solutions? And what challenges lie ahead for these spacecraft as they continue their journey through interstellar space? At every turn of this story, there is an unsolved mystery hidden. Will these Voyagers be able to succeed in revealing even more distant mysteries of this universe to us? How long will National Aeronautics and Space Administration be able to keep these spacecraft alive? The journey of Voyager 1 and Voyager 2 is not only a milestone for space exploration, but this mission also teaches us how, even with limited resources and extreme conditions, innovation and determination can make the impossible possible. The power of RTGs, radioisotope thermoelectric generators, is one key reason why the Voyager spacecraft have remained operational for such a long time. Their power source, radioisotope thermoelectric generators or RTGs, is different from our traditional solar panels, which depend on sunlight. But they can't be used in deep space. That's why RTGs were used in the Voyager spacecraft. RTGs convert the heat generated from the natural decay of radioactive material into electricity. For Voyager, the radioactive material used is plutonium-238. RTGs have provided the Voyager spacecraft with a continuous and reliable power supply, which has allowed Voyager to remain operational in deep space. This technology is especially ideal for missions where sunlight is limited or not available at all. For example, in outer planets and interstellar space, the natural decay process of plutonium-238 generates heat which is directly converted into electricity through thermoelectric materials. This process happens without any moving parts, which makes RTGs extremely reliable and long-lasting. However, over time, plutonium-238 decays, which gradually reduces the power output. But even so, the Voyager spacecraft have far exceeded their expected lifespan. This is a result of the durability of the mission's design and engineering. How do RTGs work? RTGs are a type of nuclear battery that convert the heat produced by the decay of radioactive isotopes into electricity. Each Voyager spacecraft has 3 RTGs which contain plutonium-238 oxide. When plutonium decays, it releases heat which is continuously converted into electricity through thermocouples. Thermocouples are devices that generate voltage when there is a temperature difference. When the Voyagers were launched, their RTGs were generating about 470 watts of electrical power. But as plutonium decayed over time, the heat and consequently the electrical power produced by the RTGs gradually decreased. Today, the RTGs produce about 40% less power than originally, generating only around 250 watts of electricity. But despite this, the Voyager spacecrafts have managed their power very efficiently. The mission team shut down non-essential systems immediately after their use was over, and the instruments have been very carefully prioritized so that they can continue collecting scientific data even with limited power. That's why Voyager 1 and Voyager 2 still send us valuable data from interstellar space today. The long-lasting capability of RTGs has made the Voyager mission an incredible example of how, with advanced technology and smart engineering, we can maintain our existence in deep space for a long time. Power management. The Voyager team has turned off the heaters of those instruments that are no longer in use. And also such non-essential systems like tape recorders, which used to store data before transmitting it. This careful power management has allowed the Voyagers to continue their mission despite the continuously decreasing energy reserves. Heat and thermal management is another big challenge with RTGs, managing the heat generated by the decaying plutonium. Just like on Earth, excess heat can become a problem even in the cold vacuum of space. The Voyagers are designed with a thermal control system that uses louvers for heat rejection and insulation to retain heat within the system. And this entire system regulates the spacecraft's internal temperature. This entire thermal management system keeps the instruments and electronics within their operational temperature range. As the RTG's power output decreases over time, the heat generated by them is also decreasing. Because of this, it is becoming difficult to keep the spacecraft systems warm as well. The Voyager team has to maintain a perfect balance between the spacecraft's power and thermal management so that its critical components do not fail due to excessive cold temperatures. In addition, the Voyager team has also used innovative methods like adjusting the spacecraft's orientation so that the instrument can be kept a little warm with the sun's heat as well. All of this is like a complex dance where every decision affects the spacecraft's survival and scientific output. Despite all these challenges, Voyager 1 and Voyager 2 have continued their incredible journey to this day. Software updates and problem solving from billions of miles away. Keeping the Voyager spacecraft operational was not just possible by managing power, but maintaining the health of their systems and software is just as important. In the past years, the Voyager mission team has troubleshooted many problems, sent several critical software updates to Voyager, and devised many creative solutions, all from billions of miles away. Software updates for Voyager. The most remarkable thing about the mission is that these spacecraft have received software updates despite such vast distances. In the beginning, the spacecraft had only 69 kilobytes of memory, which is very little by today's standards. To maximize the use of this limited memory, the Voyager team designed the software to be highly efficient. After the mission goals kept evolving, the team had to make several software updates so that new tasks could be performed or bugs could be fixed. These updates were sent from Earth via radio signals which take about 20 hours to reach the spacecraft. For example, when Voyager 1 was given the task to take the famous pale blue dot image in 1990, at that time, the mission team had to specially reprogram the spacecraft so that it could point its camera towards Earth. Diagnosing and solving problems remotely became more difficult as the Voyagers moved farther from Earth because the communication delay kept increasing, making real-time problem solving harder and harder. The team had to rely solely on the data received from the spacecraft to identify what was causing the malfunction in the data processing system. A series of commands was sent to reset the system, and after that, the spacecraft returned to its normal operation. This was a huge achievement, especially considering that the spacecraft was about 9 billion miles away from us. The Voyager spacecraft is now over 45 years old, and its systems have far exceeded their expected lifespan. Components like thrusters, gyroscopes, and communication systems are clearly showing signs of aging, and the mission team has to find creative solutions for them. For example, the spacecraft's thrusters, which adjust its orientation, have been working for 4 decades. Because the thrusters have become inefficient, they require more power, which is often used to perform maneuvers. To conserve power, the mission team reprogrammed the spacecraft so that the thrusters are used less frequently and there is more reliance on the reaction wheels. At another point, when the mission team discovered that Voyager 1's primary communication antenna was starting to go off target due to changes in the spacecraft's orientation. To solve this problem, the mission team developed a new strategy to keep the antenna pointing correctly using a combination of thrusters and reaction wheels. Innovative problem solving meant the Voyager mission team had to get creative to solve the spacecraft's aging system problems. In some cases, the team even developed entirely new techniques to minimize hardware failures or limitations. For example, when signs of wear appeared in Voyager 2's gyroscopes, the team developed a new method to determine the spacecraft's orientation. They repurposed the data from the star tracker, which was originally designed for a different purpose, so that the antenna keeps pointing towards Earth and communication remains possible. In 2019, when Voyager 2's power levels suddenly started to drop, several of its instruments had to be shut down because of it. The mission team identified that due to the sudden voltage drop, the spacecraft had triggered a power protection mode. To prevent this problem, the team reprogrammed the spacecraft so that critical systems could be given priority and the instruments would remain operational under all circumstances, no matter how much the power levels fluctuated. This is one of the biggest challenges for the Voyager mission team. Maintaining continuous communication with Voyager, especially over such vast distances as Voyager moves away from Earth, is a major challenge. The travel time of the signals is also increasing and the strength of their signals is continuously getting weaker. Because of this, communication is also becoming increasingly difficult. To communicate with the Voyager spacecraft, National Aeronautics and Space Administration primarily uses its Deep Space Network, or Deep Space Network, which is a global system of large radio antennas located in California, Spain, and Australia. The Deep Space Network is a critical component of the Voyager system, providing a link between Earth and the distant spacecraft. As the Voyagers traveled farther from Earth, they also upgraded their equipment to maintain communication at all times. For example, in 2012, National Aeronautics and Space Administration upgraded the Deep Space Network antennas with new receivers that were more sensitive. These could detect even faint signals from Voyager 1 and Voyager 2. The Deep Space Network antennas are also equipped with powerful amplifiers that boost the signals sent to the aircraft, ensuring that the commands can reach their precise location even across billions of miles. Signal delay and data transmission is a unique challenge when communicating with the Voyagers, and that is the significant time delay involved in the exchange of signals. Currently, it takes about 21 hours for a signal to travel from Earth to Voyager 1 and another 21 hours for the response to come back. This round-trip delay is about 2 days, which makes real-time communication almost impossible. And because of this, the mission team has to carefully plan and sequence their commands. To maximize the efficiency of data transmission, the Voyagers use a technique called data rate reduction. In this technique, scientific data is compressed before being transmitted, allowing the spacecraft to send more data in a shorter amount of time. Deep Space Network then decompresses and processes this data on Earth, ensuring that no valuable information is lost. To maintain a stable communication link with the Voyagers, precise antenna pointing and tracking are essential. As the spacecraft continuously travels through space, we have to constantly change the orientation of our antennas to keep receiving signals from there, which means the Deep Space Network has to constantly adjust the position of its antennas as well. To keep the focus on the spacecrafts, the Voyager mission team has developed sophisticated algorithms that precisely predict the spacecraft's trajectory and orientation. These algorithms take into account the gravitational influence of planets and celestial bodies, as well as the spacecraft's own movement, and ensure that the antennas remain accurately locked onto their target. In 2020, the Deep Space Network made a major upgrade to improve its capabilities, in which National Aeronautics and Space Administration added a new 34-meter antenna in Madrid, Spain. This upgrade further enhanced the capabilities of the Deep Space Network so that they can easily communicate with distant spacecrafts like Voyagers and ensure that they stay in contact with Earth for as long as possible. Future of Voyager missions now, as the Voyager spacecrafts continue their journey into interstellar space eventually. One day, their power level will drop below the minimum threshold needed to operate the instruments or to communicate with Earth. National Aeronautics and Space Administration estimates that after 2025, the RTGs won't have enough power left to keep the spacecraft systems operational. And when that happens, the Voyagers will go silent and their historic mission, which was providing us with valuable data, will come to an end. But even after the power runs out, the spacecrafts will continue to wander through this infinite space with their golden records, which are a message from our human civilization to future aliens, a testimony of our existence for those intelligent aliens who might someday reach these spacecraft. The journey of the Voyagers represents humanity's first step into interstellar space, which is beyond the boundaries of our solar system. They have expanded our understanding about the outer planets, about our solar system, and have revealed many mysteries of the heliosphere. This mission also gave us valuable data on the Kuiper Belt and interstellar medium. Their legacy will continue to inspire our future scientists, engineers, and explorers. In conclusion, as we look towards future space exploration, the Voyagers remind us that when we push the boundaries of our knowledge and capabilities, nothing is impossible. Their remarkable journey demonstrates the power of human curiosity and ingenuity, and their story is not over yet. Even after falling silent, the Voyagers will continue their journey through this cosmos. Friends, as we send our message to the stars, what are your thoughts on this? Be sure to let us know in the comment section. If you like this video, be sure to like it and share it with your friends. For more videos like this, subscribe to the channel and don't forget to hit the bell notification so you don't miss more deep dives into space exploration and science discoveries. Friends, we'll meet again soon with another new informative video. Until then, stay curious, be happy, and goodbye.